Let's take a look at how you can save data when you're making iOS apps. One of the easiest ways to save data in an iOS app is to use something called SQLite. Now, SQLite is basically a simple SQL database where you can write queries from your Swift code and persist that data to disk. So when your user opens your app, does some stuff, closes it out, when they come back, they can look at that data that they saved. So to start, let's look at just a few different queries that you'll probably write while you're writing some SQLite in your apps. The first query is a create query that's used to create tables. So here we're going to create a simple users table. It just has two columns. One is an ID, and this is just a unique ID for each user. You can see here that the type is an integer. We're using it as our primary key, so this is sort of a unique key that's used to identify each row, and it's auto increment. And that means that each time we insert a new row into this table, we're automatically going to create a new ID that's one more than the ID before it. Our other field in this table is just a text field. We called it name, so we can give our users a name, and we can put in any amount of text we want there. And then finally, the start of this query just says we want to create a new table, but if the table already exists, then don't worry about it. We're not going to do anything, and we're going to call that table users. So that's how we can create a table pretty simply in SQLite. The next query we're going to look at is inserting data into the table. To insert a new row, we're going to start our query with insert into, followed by the name of our table, so that's users, and then a list of the columns we want to supply values for. So here we're just going to supply one column, and that column is called name. Then we'll say values, and then followed by the values we're going to insert. So here we're inserting one new row, and for the name column, we're inserting a value of Tommy. After we insert data into the table, we probably want to read that data back somehow. So this is what a select query looks like. We're going to start by saying select. Our star says just give me all of the columns you have. We'll say from users, which is the table we want to read data from. And then we'll have a where clause that filters down those rows. So this says only give me the rows where the name column is equal to the text Tommy. After that, we have an update query. So we want to start our query by saying update. Then we have the name of the table, which is users. Then we're going to say set and say our column name, which is name. And let's say a value of Tommy M. And then we want to filter down to some list of columns or some list of rows. So we'll say where name equals Tommy. So this query says for every row where the name column is exactly the string Tommy, I want to change that and update it to instead be Tommy M. And so these queries are fairly simple, and you'll often find that the queries you're doing in your app are also pretty simple because you're usually just sort of storing values and reading them back, and oftentimes you're not doing more complicated SQL operations, which is nice. So let's now take a look at an example of how we can call those SQL queries from our iOS app. And the app that we're going to be making here is a notes app. So this is an app that's it's already built into iOS. It's pretty simple, but you'll be able to create notes, write down some note. It'll be saved to a SQLite database, and then you can browse and read them later. So let's jump in. First, we'll open up Xcode. As always, we're going to start by creating a new Xcode project, just a regular single view app, and we'll call our project Notes. Just save it on the desktop as we've been doing. And by now, we're pretty familiar with the code that's generated. So let's first open up that storyboard and think about what we want our app to do. So the first view in our app is going to be a table view. That makes sense because each row is just going to represent a different note. And then we're also going to have another view controller in the app, and that's going to be the actual note view itself. So it'll be basically a big editable text field where you can type in a note, and then when you go back to that table view, we'll make sure to save that note to disk. So a lot of this should feel pretty familiar, so let's jump in. First thing we want to do is change to a table view controller, just like we did before. So let's just delete that. Come up to our top right, create a table view controller. We know that we want to have some kind of navigation controller, so again, we can just embed in a navigation controller. By the way, you can also just add a navigation controller from this view, and we'll actually automatically create a table view for you as well. So just like before, let's set some properties on that cell. We're going to say it's same, that basic style we had before. Let's call it a note cell. Set our accessory to a disclosure indicator, just like we had before. And now let's give this a title, which is Notes. So that's a start. That's our first screen, and those are all the views for that first view controller. Next, let's create our model. So let's create a new file, just an empty Swift file that we can use for our notes. So let's just call it note.swift. Now maybe to start, let's just define a struct where we can have a note. We can have a couple different fields in that note. First, we're going to have an ID. It's going to be an integer, sort of just like the queries that we just saw. And then the other field can just be the contents of that note. And we'll just use a string for that. So that's our struct. Let's come back to our view controller. So just like we did before, let's make this table view controller. We're going to store in memory a list of all of our notes so that we can display them in the table. So let's do that. Let's say that we have some notes. It's a list of note, and it's initially empty because we haven't loaded anything. Now remember those three methods we have to implement on a table view controller. The first is number of sections. It's just one. We're not worried about sections right now. Second one is the number of rows in each section. Now, just like before, the number of rows in our table is just going to be the size of this notes array. And basically, as the user is adding notes and saving them, we're just going to continually update this notes array. So finally, the third method we have to implement is the cell for row at index path. And recall that all we're doing here is we're grabbing that cell from that pool. We're going to change some properties on that cell based on the data and then return it. So remember that to grab a cell, all we say is table view, DQ reusable cell. We had an identifier of note cell, and we can pass in the index path. We can say we want the text label to just be our notes. Remember, we're using indexPath.row because we're using rows and not worried about sections right now. And then we can just set it to be the contents of that note and return a cell. So this is all really similar to what we saw in our Pokédex app because it's just sort of a standard simple table view. So let's just run this just to make sure that everything displays and nothing looks off. So here's our app in the simulator. But you'll notice that it's totally blank. So something happened here. So let's see what our console says. This is a pretty helpful error message. It says, failed to instantiate the default view controller. Perhaps the entry point is not set. Now remember what we did last time after we created that new view controller in our storyboard? We made sure that we set that isInitialViewController to be true. So if we come back over to our navigation controller, open up the right-hand panel, and just make sure we have isInitialViewController checked. Now, after we've done that, we can rerun our app. And there we go. So this is a pretty skeleton version of our notes. And so now what we need to do is actually write the code to create, read, and update notes for the user. So let's start by creating a new class that's going to have methods for different operations on our notes database. So let's jump back to our model file here. And in addition to having a struct representing an individual note, I'm going to create this new note that this new class that I'm going to call Note Manager. And this is basically a class which, as it sounds like, for managing notes. So this is going to handle connecting to the database, creating notes, getting all the notes, and updating a note. So those are basically the methods that we're going to want to have in this class. Let's start by writing a method to connect to a database. With SQLite 3, your database is just a file on the user's phone. So you can think about this as just opening up a file on disk and then using that as your database. So let's start by creating a method called connect. And let's get a path to some file on the user's phone. So let's create a variable called database URL. And we're going to use a built-in iOS class here called File Manager, Default, and URL. So there's a few different parameters here that basically allow you to specify where you want this file to be stored. So this first one says what directories do we want to use. So we want to just use the user directory. Wouldn't really make sense to put this in music or photos or something. And so this directory is basically some space for your app to store some user-specific files. Next is just some more search paths. So we just want to use the user domain mask. Again, we're just putting everything in sort of the user's path. These next two parameters, don't worry too much about. We can just say nil here, that doesn't matter. And this last parameter says, if this file doesn't exist, do you want to create it? Which we do. So that's going to give us a path to some folder on the user's phone. But what we really want is a path to a file. So to do that, we're going to say appending path component. And then we're just going to call this file notes.sqlite3. So what this kind of long method is really doing is it's just a way to get a path to somewhere on the device where it's safe for you to save, read, and write files. So you'll notice here that the compiler says a couple things are wrong here. And the main one is that we need to add a try-catch. So again, something could go wrong in this place. There could be a reason that you can't save files, you don't have access to somewhere on the user's device. So if that happens, it's going to throw an exception. So we just need to handle that. So just like we did before, we're going to put this inside of a do block. And then we're going to catch the error. And then we'll just print out could not create database. Again, if this were a real app, you'd want to display some sort of error message to the user, but we're not worried about that. And then lastly, we just want to put a try in front of this call. And so now our build succeeded. Now that we have a path to a file on disk, we now want to establish a connection to that database and open up that file. So to do that, we want to have inside of this class a handle to a database, or just some sort of reference to one database, so you don't have to keep connecting over and over again, since connecting can be kind of slow. So we're going to create a new variable called database, and the type of this variable is opaque pointer. So this basically says that this is a pointer to something, but we know that this is going to be a reference to our database. So with that, we can start calling some SQLite 3 functions. So before we do, we just have to make sure that we import SQLite 3, and now after we have that line, we have access to all of those functions. So let's start. So the first function we want to call is SQLite 3 open. And this is going to take two parameters. It's going to take a file that we want to open up, and then as its second parameter, we're going to say where we want to establish a connection to the database. So the first thing is just going to be that file name we just created. And then the second thing is going to be our database. So a couple things here. So first, we want to change this URL to a path. So all we have to do is say url.path. And then second is we want to give it a reference to that database. So this is basically the same as pointers are in C. We want to give a pointer to this function so that it knows where to open the database. So if we just put an ampersand here, that's going to say, all right, here's the address of where I want you to store this connection to the database. Now, with SQLite 3 functions, they can return a few different values. So we always want to make sure that they're returning what we expect and not erroring out. So to do that, we're just going to put it inside of an if. So we're going to say if the open was successful, so there's SQLite OK. So that means we're good to go. If not, again, you want to handle this somehow, but we'll just print out could not connect. OK, so now that we've opened the database, the last thing that we want to do is create a table. So we're going to use one of those create table statements that we looked at earlier. So let's say SQLite 3, we're going to use exec. So this is basically saying I want to execute some query on the database. The first thing we need is a pointer to the database to use. So we're going to use that database pointer we created. Next is going to be the SQL to execute. So here, I'm just going to create a table. I'm going to say create table if not exists notes. And we're just going to have one column in our table here. We're going to call it contents, and it's going to be text. Now, with SQLite 3, it's actually going to automatically create an ID column for you. And that column is going to be that integer auto increment, and it's going to be called row ID. So normally I'd create my own ID column here, but because I know SQLite 3 is going to do that for me, I'm not worried about it. So last, there's a few other things here. You don't have to worry about these. They're just sort of different options that we're not going to end up using, so we can just pass nil to all of them. So let's just make sure that this worked. So again, let's just put this in an if, make sure that it's OK. If it's not, you can print out could not create table. OK, so that's it for our connect method. So now we've basically just got a path to a database file in the user's phone. We've opened it up, and we've made sure that the table that we need to exist exists. Next, let's write a function for creating a new node. So to do that, we want to make sure that we're using this same database pointer, because if we're not, we need to reconnect over and over again. That's going to be slow. So let's create this function here. We're going to call it create. So the first thing we want to do is call connect. So this makes sure that there's a database pointer, but we only need to connect once, so we can do something simple here, which is say that if database isn't nil, then we're done. So this just says if we've already connected to the database, don't do this over and over again. So any of our other database functions can just call connect and not worry about it, because we know that connect isn't going to redo something if it's already been done. After we connect to the database, there's a three-step process to executing queries. We're going to prepare the query, then we're going to execute the query, and then we're going to finalize it. So the first thing we want to do is prepare it. So to do that, we're going to create a new variable called statement. It's going to have that same type before. It's basically just a pointer to somewhere in memory. And now we're going to say SQLite 3 prepare. You notice there's a few different prepare functions. We're just going to use v2. That's kind of the standard one. And so looking at these arguments, looks like the first argument is a handle to that database. So we can safely use this here because we know that we've called connect. Next is the SQL that we'd like to run. So we're going to write an insert statement. So we're going to say insert into notes. The only column we care about is contents. And then we'll supply values of, let's just say, new note. And so this means that every time we create a new note, we're just giving it some default text called new note. These other things here we don't have to worry too much about. Can just pass a -1 here. We're not worried about what that is. We can pass our statement, and then we can just pass nil. So we're not really worried about that -1 or nil. So now, just like we did before, we just want to make sure that this function doesn't return any errors. So we'll surround it with an if and say that if it is OK, then we can move on. And let's just do a build just to sanity check. Looks like we have an error here. Okay, so it looks like here we forgot that we're passing a pointer, so just pass in the ampersand to just get the address of that so that the function can use that pointer. Okay, so now we have a prepared statement, and now our statement is ready to execute. And the way to do that is by calling this function called SQLite3 step. So we're going to say if SQLite3 step, and here it just takes one argument, and that's actually just the statement. And then let's just make sure that this is okay. Then we're good. So before we forget, let's just add a couple print statements. Again, you really want to handle these errors, but we're just going to print them for now. So we can say could not insert note. And we want to say here something like could not create query. So for example, if there's a syntax error in your query, one of these might trigger. Now the last thing we want to do is just finalize that statement. And once you finalize a statement, it's basically going to do some cleanup work, and it means you can't use the statement again. To do that, it's also pretty simple. I'm just going to finalize the statement. So now you'll notice that the structure of this is a little weird. So let's just kind of change up how our logic works here. So actually, the first thing is we want to change this to done. And let's just kind of flip the logic here. So we'll say that if this didn't work, then let's print could not insert note. And then let's similarly say if this didn't work, then we can say could not create query. And we can just sort of return. And this is kind of nice because you're going to avoid having some crazy number of nested indents. So we can get rid of that and that. Okay, so as one last thing, often when you're inserting a new value, you immediately want to access the ID of the row that you just inserted. So to do that, let's make our create function actually return an int. And the value we want to return is going to be SQLite3 last insert row ID. And we can just sort of pass in that same database. And so this is nice because now we're saying, well, we just created a new row. Maybe you immediately want to update it or do something with it. So this can tell you that ID. But again, we have this error here. All we have to do is wrap this in an int. You'll notice here that this function is returning a different type of number. Really easy to just cast to an int by surrounding it with int. And then let's say, -1 here to indicate that the node couldn't be created. So now let's just do a quick build, make sure we're good to go, and we are. Okay, so now that we've written a method to create new nodes, let's write our next method, which is to get all of the contents from the database. So let's say we want to have a function called getAllNotes. We know that this is going to return a list of notes. So just like before, we want to start by connecting to the database. And remember, this, if it's already connected, this function isn't going to do anything. Next, let's create a statement, just like we did before, and prepare it. So we'll say, let's prepare. We'll use the database. And this time, the statement that we want to use is a select. So we're going to say select. We'll use that automatically created ID, that row ID, as well as the contents from notes. And so this will just grab everything in the database so you can access it. Just like before, don't worry about what this is. We'll give it a pointer to that statement so it knows what to prepare, and then we don't need this either. And then again, we just want to make sure that if this is not SQLite, okay. Basically, if some error occurred, you can print error creating select. And we'll return some empty array. Next, just like we did before, is we want to call SQLite3 step to actually execute the query. Now last time, because we were just running one insert, we could just call SQLite3 step once. But this time, we want to run it for every time there's a row available to read. So to do that, we're going to use a while loop. So we can say while SQLite3 step of our statement, is equal to a row. We now want to, this means we have a row, we've accessed it, we want to convert that to our note object. So first, let's just create a new variable where we can store our result. So this is what we're ultimately going to return from the function. It's going to be a list of note, and it's initially going to be empty. So now, each time that we do have a row from the database, we're just going to add that onto this result. So we can say result.append, and what this is going to do is add on a new element to our array. So these arrays don't have to be fixed size, as we saw. We can sort of change them and add and remove things. So this is just going to add an element to that array, and we want to add a note. And just like before, we have this nice constructor that was generated for us by the struct. And so now we want to access the row ID for ID and the string for contents. So again, we're going to use some SQLite 3 functions here. So we're going to say SQLite 3 column int. And so what this is saying is it's saying I want to get the value at some column, and I know that it's going to be an integer, so give me back an int. And that works out because our struct takes an int. So again, we're just going to use that same statement as before. And now we're going to take a 0-indexed list of columns. So the first column in my select is row ID, so we're going to pass a 0 here. So that's our ID. Next, we want to grab a string. So we're going to say, similarly, SQLite 3 column text, same thing as before, statement, and now our contents is the first column. So now one last step is we want to take this string and just convert it to a native Swift string. So all we want to do is say string, and what's coming back now is called a C string. And so what's nice is that string has this constructor that just takes a C string and converts it to a regular Swift string. It's sort of this lower level API, similar to how we're using pointers and strings in C. And so this is just an easy way to convert them. And then last, we have the compiler, hopefully telling us to just make sure we wrap this in an int, which we've done. So now if we build this, as the compiler is reminding us, the last thing to do is just return that result. But before that, just make sure we call finalize on the statement just to do any cleanup behind the scenes. So now if we run build, we're good to go. So every time you're writing these SQLite 3 queries, you're basically going to be following this same pattern. So you're going to take a statement, you're going to prepare it, then you're going to execute that statement, either in a loop or just once. Then you're going to grab, if it's a select query, grab some of those column values, and then lastly finalize it. So that sort of pattern is going to apply no matter what you're doing with SQLite 3 on iOS. So now we've got enough to populate our table view, because we can start creating notes and then we can fill them up or display them in the table view with this getAllNotes method. So let's start doing that. The first thing we want to do is to create a button to create new notes, because right now there's no way in the UI to add a new note. So we're going to use a bar button item again. So just come back here, bar button item, add that up here in the top right. And now we can take advantage of some built-in system icons in iOS. So if you come over here to system item, rather than being custom, if you just set it to add, you get this nice looking plus for free. So no need to download images from the internet or something like that. So that's done. And now let's add an action. So notice here we're out of our model, we're back in our controller, and we're going to create an action. Let's call it create note. And now we want to create a note. So the first thing we want to do is somehow get an instance of that note manager. Right now we have a bunch of methods, but we don't have any note managers created. But remember we talked about how we want to save this connection to the database, since connecting can be kind of expensive. So what we want to do is actually create an instance of Note Manager inside of itself. And if you're familiar with object-oriented programming, this is something that's called a singleton, which means that we have this class, but there's only ever going to be one instance of it. And we've actually already seen singletons. This, for example, is one. File manager is a class. And by saying default, we're saying give me that one instance of that class. So we're basically going to follow the same pattern here. To do that, we're going to say static let, and let's just call ours default. Or let's call it main. You can call it whatever you want. And then we're going to set that equal to a note manager. So it's kind of this cool thing where a note manager has a reference to itself. And by saying static, that basically enables you to access this property without an instance, which makes sense because if you had an instance, you wouldn't need another instance. And so similarly, how you could say class.default here, we're going to be able to say notemanager.main here. One other thing you might want to do if you're writing singletons is just to make it so that no one else can instantiate your class. So to do that, you can create that init method, but mark it as private. By prefixing this with private, we're basically saying nobody else can call this. So even if you try to instantiate a note manager, the compiler is going to tell you that you can't. This is just kind of a nice thing to, if you're giving an API to somebody else or even just working with somebody to sort of enforce and remind them that they should be using this singleton instance and not trying to create note managers themselves. Okay, great. So now we have an easy way of accessing the note manager. We can just say note manager.main.create. And that's going to create a new note. And it's going to give us back an ID, which we're not too worried about right now. So we can just say let underscore equals that. And we're never going to use the value of that underscore. So now what we've done is we've inserted something into the database. And now what we need to do is reload the table view, just like we did before. So let's write a method that reloads the table view. And this method needs to do two things. The first thing it needs to do is say, give me all of the notes that are currently in the database so I can display them, and then let me tell the table view that it needs to reload its data because you've changed that underlying data structure. So let's do both of those things. Recall that we had this property called notes, and this is going to hold all of the notes that the user has created. And let's set that equal to notemanager.main.getAllNotes. Makes sense. That's just going to return a list of notes, and so we want to save that. After that, we want to call self.tableView.reloadData, just like before. You'll notice that we didn't need this dispatch.main.async thing this time. The reason is that we're not inside of a background task at this point. Everything happening here is in the foreground, and so there's no need to sort of jump back into the foreground because we're already there. So after we call createNote, we just want to call reload, and that's going to reload the entire table. Didn't end up using viewDidLoad here, so let's just remove that for now. So one last thing to do before we can run this app is remember to hook up this IB action. So let's jump back to our storyboard. Let's select the table view controller. And first, let's make sure that it's using the class that we specified. So let's change the class to viewController, which is the class that we were just writing. Then let's control, click, and drag from the plus over to the viewController, and there's our sent action, createNote. Okay, so let's run our app and see what happens. So here's our empty table view, just like before. Let's try pressing the plus. Okay, so that's not great. It looks like we got some error messages, and these are error messages that we wrote, so that's helpful. So let's just jump back into our model. And, so this was, I was wrong before. You want to save this in the document directory. So this is just basically a directory where apps do have permission to read and write. What was happening is we were trying to save it somewhere where we didn't actually have permission to do that. So let's try again. Let's rerun this. And OK, so if we click plus, there we go. So now we have added a new note. So what we've just done there is we've inserted a note into the database. We've notified our table view that we need to reload, and then we reloaded all of the notes back from the database so that the table view is displaying the most up-to-date versions of all the notes. So let's just sanity check to make sure that these notes are sort of behaving as we'd expect. So let's stop the app And now when I rerun it, I should see the note again, because that means that we're saving it to disk. So let's click run. Okay, and that's interesting. It looks like we don't see the note. So now let's see. Doesn't look like there's anything wrong in our model because none of these print statements triggered. So maybe it's in the controller. Let's jump back to the controller. And aha. So what's happening is we have this reload method, but we're never loading it for the first time. So when that view is created, we want to make sure that we load the notes from memory, right when that app starts up. So right now what's happening is it's starting up, it's saying, well, my notes is set to an empty array. Okay, guess there's nothing to display. And so let's change that. So let's say on view did load, make sure we call the super method, and then let's just say reload. And so what this is saying is when the app first starts up, fetch all the notes from the database, tell the table view it's time to update. So now let's run this. And there we go. Just as we expected, there's our note. If we stop this and we create it, stop this and rerun it rather, there's our note. So there's one last piece of the puzzle here, which is creating a view controller to display and allow the user to edit the contents of their note. And again, some of this should be pretty familiar. So let's first jump back to the storyboard. Let's create a new view controller. Add it there. Remember, we want to add a segue here. So we're going to control click, add that show segue, give it a name. So we'll just call it something like note segue. Let's create a new Swift file. And let's call it note view controller. Okay, here's our note view controller. We're going to say note view controller extends UI view controller. Make sure we've imported UIKit. Everything builds, that's great. Come back to the storyboard and make sure that in the identity inspector, we have set this to note view controller. Okay, so now let's add a text view that will display all of the contents of this note. So here, let's type in text view, let's drag this over. And so now what we want to do is we want this text view to fill the entire screen, much like it does in the iOS app. And so to do that, we're going to use something called constraints. So if you come down here in the bottom right, you can see a few of these little buttons, and this third one here says add new constraint. So let's click that, and we get this little popover. And what we want to do is we want to say, let's set the top of this view to be the top of the iPhone, the bottom of this view to be the bottom of the iPhone, and same for the left and right. So to do that, we can just constrain all four of these things to its parent. So when we say add constraints, we can see these sort of little lines that indicate that they're gonna sort of stick to the edges there. So now we can just sort of drag this over, and we're good. So we can get rid of this sort of default text, just kind of silly. Get rid of that, and then we'll also make sure that our text view is editable, which it is. And so now our view should all be connected. So let's jump back to the model and write the last query that we'll need to write, which is to save a note to a database. So we're back in our note manager here, and we're going to create a new method called save. This method is going to take one parameter, and it's going to be a note that we'd like to save. So we're going to say note here, and it's going to follow that same pattern that we saw before. We're going to call connect. That's going to establish a connection to the database. we're going to create a statement. It's an opaque pointer. We're going to try preparing a statement. So SQLite 3, prepare. It's going to take a database. And now we're going to write an update statement. So we're going to say update notes. The only thing we really need to set is the contents. So we're going to say set contents. Now we're going to add a question mark here. We'll come back to that later. Where row ID equals question mark. As always, we don't worry about this. This is a pointer to our statement. This we don't need. And so we'll make sure that this is okay. This error messages helped us last time, so I'll do it again. Okay. So now what we want to do is we want to bind data to this query. So these question marks here are just a nice way of passing data into a query. You could use something like string interpolation, but it's kind of insecure and you're opening yourself up to someone sort of doing things with your app that you might not want them to. You're basically open to a SQL injection attack. And so we want to instead use parameter binding to safely pass data into this query. So the way to bind data to a query is by using the SQLite 3 bind methods. So we can say SQLite 3 bind followed by that data type. So we're going to say use the statement. The next parameter to this function is going to be the index of the question mark you want to update. So what's kind of annoying about this is a 1 indexed list where the other one was a 0 indexed list. So to bind to the first question mark, you actually want to say 1, which is really easy to forget, but hopefully these error messages will help you out. So then we'll bind that. The next thing is going to be the value we want to bind. And similarly to here, how we wanted to change a regular Swift string into this C string, we're going to do the same thing here. So the way to do that is to first create an NS string from a regular Swift string. So we're going to say note.contents here. And then from there, you're going to call this other method called UTF-8 string. Again, you don't really have to know the details of what's going on here, but basically you're just converting formats, converting the data between a Swift-friendly format and then the SQLite 3 friendly format. Same as always, we're not worried about these last two parameters. So that's binding the first parameter. Now let's bind the second parameter. So let's bind the integer. This is a statement. Again, we're using a 2 here because it's a 1 index list. And now we want to set note.id. Let's build just to make sure. It looks like instead of an int, we need to use an int32. Easy to fix. Just surround your int with that. Now that you've bound the parameters to this query, you want to execute it. So remember, to do that, we're going to use the step function. Pass in that statement. And then we want to make sure that it's done. If it's not, then we'll say error running update. Finally, we just want to finalize that statement to do that cleanup. Okay, and so now what this was going to do is you can pass it in an instance of a note, and we're going to write those values to disk using an update statement. So you can change the value of a note that's already exists. So that's it for our model. We've written the 3 model methods we needed to write. We can create notes, we can get notes, and then we can save notes. So the last thing to do is wire all of this up to our views through our controllers. So we created that segue in the storyboard, and so now we want to utilize that segue to pass the note from this list to the other view controller. So remember that method was called prepare for segue, let autocomplete do the work. We want to check in on that identifier. That identifier, we called it a note segue. That's true. Just like last time, we want to cast that destination view controller to an instance of our note view controller. So let's do that. If let destination is segue.destination as note view controller. And so now here is where we can pass the note. So let's jump to this view controller, add a parameter for that note. Make sure that exists. While we're here, let's also define an outlet because we know we're going to need to connect that later. So let's say there's an IB outlet for the text view. Now from our view controller, we can say destination.note. Just like before, we're going to use notes, and the index we're going to use is tableview.selectedIndexPath, or index path for a selected row, and we just need the row. So that's going to pass over the note data to our second view controller. Okay, so we've passed the note, so let's jump back to our note view controller. Let's fix this typo. So now let's bind that text that we received from the note to our text view. So we're going to say on view.didLoad, call super, then text view dot text is equal to note dot contents. So now this just says whenever the view is loaded, let's set the contents. Now the other thing we want to do is save the note when the user exits the view. So to do that, we're going to use another iOS method that's called for us called viewWillDisappear. And so this is going to be called automatically right when the user hits that back button and before the view has disappeared. So just like before, we're going to call super, pass in that animated parameter. And then we're going to say note manager, just like before, main. And now we're just going to save the note that we currently have. So let's build. Looks good. Now lastly, let's not forget to connect this outlet. So come back over to main. We're going to select our note view controller, and then we're going to drag and connect the text view property. And now one last thing we need to do is make sure that we update that first view controller every time the user comes back to it. So before we used view.didLoad, but this is only going to be called once, which is the first time that this view controller is created. But when the user is jumping back and forth between these view controllers, every time you come back to the first one, you want to reload the data to make sure that it's updated. So rather than using view.didLoad, we're going to use viewWillAppear. So it's sort of the opposite of viewWillDisappear, but every time this view comes into focus and into the foreground, this method is going to be called. So let's change our super view.didLoad to super viewWillAppear. Just pass along that animated parameter. And now we can try running our app and see what happens. So here's the app in the simulator. From before, we had that new note. We've persisted that, so that's going to be around. So let's click that. Great. Looks like we've passed the data from that first note into the second view controller. Now let's try typing. Say this is a new note. Click back. Doesn't look like it worked. So even though we changed the text when we came back, looks like the note that was displayed was this new note. So let's see what happened. Let's jump into our note view controller here and take a look at what we're doing. Looks like when the view loads, we're setting the text to be equal to the contents. That looks right. Then when the view disappears, looks like we're saving the note, but we never changed that note object. So what's happening is when the second view controller receives that note object, it's just going to display it, and then no matter what the user typed in, just save it right back to disk without being changed. So what we want to do is actually change this note object. So we want to set its contents to be equal to the contents of that text view. So we'll say note.contents equals text view.text. Now if we build here, I think this is the first time we've seen this, but we noticed in the struct that we created let variables, which means they're immutable. So here the compiler is telling me that I declared contents as a let immutable variable. Instead, I want to declare it as a mutable variable with var. So I'll come back to my struct, change let to var, and try rerunning again. Here we go. So let's go into our new note, change this to this is my new note. Back up, and it looks like we're working. So just to make sure, let's create a new note by tapping on the plus. Let's save this one as note 2. And there we go. It looks like everything worked. So there's our fully functional Notes app using SQLite to save data on the user's phone.